Hello there and welcome back to the Science Sleepy Minds. You're lying in bed right now, staring at the ceiling, and somewhere in the back of your drowsy mind, a question starts to form. You think about the ground beneath your house, the layers of rock and sediment stretching down for miles, compressed time stacked like the pages of an impossibly old book, and you wonder, what if someone else read that book before you? What if they wrote in it, lived in it, built cities and dreamed dreams and gazed up at stars that have since burned out? What if we are not the first? It's the kind of thought that keeps certain scientists up at night, which is ironic since we're here to help you sleep. But don't worry, you probably won't survive the existential weight of what we're about to explore, not because it's dangerous, but because your pillow is soft, your blankets are warm, and deep time has a funny way of making everything feel wonderfully, terrifyingly small. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop a comment telling me where you're listening from and what time it is there. I always love knowing that someone in Tokyo is drifting off at 3 a.m. while someone in Buenos Aires is just settling in for the night. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You find yourself standing in a laboratory, though it feels more like a library. Papers everywhere, coffee rings on notebooks, the faint hum of computers running simulations. The year is 2018, and two scientists named Gavin Schmidt and Adam Frank have just published something peculiar. It's not a discovery exactly. It's a question dressed up in mathematics and geological reasoning. They call it the Silurian Hypothesis, named playfully after those intelligent reptiles from a certain British science fiction show. The question is devastatingly simple. If an industrial civilization existed on Earth millions of years before humans, would we even know? You lean over their shoulder, metaphorically of course, because time travel isn't real, or at least you're pretty sure it isn't, and you read their reasoning. Earth is 4.5 billion years old. Human civilization, the kind with cities and writing and smartphones, is maybe 10,000 years old if you're being generous. Industrial civilization? Roughly 300 years. That's a blink. That's less than a blink. If Earth's history were compressed into a single calendar year, all of recorded human existence would occupy the final seconds before midnight on December 31st. You'd miss it if you sneezed. The Silurian Hypothesis doesn't claim that ancient civilizations definitely existed. Schmidt and Frank are careful about that, almost frustratingly so, in the way that good scientists tend to be when they know they're poking at something strange. What they argue is that we haven't actually looked. We've assumed we're first because we've found no evidence to the contrary. But the absence of evidence, as the old saying goes, is not evidence of absence. Especially when you're dealing with timescales that make the human mind go a little wobbly. You try to imagine it. Picture a city, gleaming and alive, filled with beings whose names you'll never know, because language itself has been recycled 1,000 times over. They have technology, maybe. They burn fuel, perhaps. They look up at the sky and wonder if they're alone in the universe, never suspecting that the true mystery isn't out there among the stars but buried beneath their feet, waiting to be forgotten and then forgotten again. Now fast forward 100 million years. The city is gone. Not ruined, not buried. Gone. The tectonic plates have shuffled like cards. The mountains that once framed the skyline have been ground to dust and reformed into entirely different mountains on an entirely different continent. The ocean has swallowed the land and retreated again, leaving behind sediment that will one day become limestone, carrying within it the fossilized shells of creatures that have no memory of what came before. Historians still argue whether the archaeological record can ever be considered complete, and the Silurian Hypothesis suggests the answer is a resounding no. Not just incomplete, fundamentally, structurally incapable of preserving certain kinds of truth. You think about your own house, your own city. How long would the concrete last? The steel beams, the plastic bottles you threw away last week without thinking. A few thousand years maybe, a few million if you're lucky. But 100 million? The numbers stop making sense at that point. Your civilization becomes a smear, a chemical anomaly, a thin dark line in a cliff face that some future geologist might notice if they happen to be looking at exactly the right rock on exactly the right day. The quirky thing about Schmidt and Frank's paper is that they weren't trying to prove ancient civilizations existed. They were trying to figure out what signs we should look for if they did. They approached it like detectives examining a crime scene where the crime happened so long ago that even the concept of crime has been forgotten. What fingerprints would an industrial society leave? What clues would survive the grinding patience of geological time? You settle deeper into your blankets, feeling the weight of this question pressing gently against your consciousness. It's not scary, exactly. It's more like vertigo, that sensation of standing at the edge of something vast and realizing that the edge extends in every direction, including backward through time. You're here now, alive and wondering. But you might not be the first to wonder, and the ones who wondered before you might have left no trace at all. Their questions dissolved into the same silence that will eventually claim yours. The thought doesn't keep you awake. Strangely, it does the opposite. There's something almost peaceful about it. This reminder that the universe is older and stranger than you can possibly comprehend. You don't have to solve the mystery tonight. You just have to let it wash over you. Soft as the hum of that fan in the corner, gentle as the darkness settling behind your eyes. The laboratory fades, and you find yourself somewhere else now. Not a room, but a concept. A vast and patient force that has been working quietly since the moment Earth first cooled from a ball of molten rock. You're standing in the presence of deep time, and deep time does not care about you. It doesn't care about anyone, it simply erases. You watch as continents drift like thoughts across the face of the planet. Africa kisses South America goodbye in slow motion, a breakup that takes 100 million years. Mountains rise like bread dough, pushed upward by the collision of tectonic plates, and then just as slowly they crumble. The Appalachians were once as tall as the Himalayas, you know. Now they're gentle rolling hills, worn down by rain and wind and the inexorable patience of entropy. Give the Himalayas another 200 million years, and they'll suffer the same fate. Nothing is permanent, not even stone. This is the first problem with finding evidence of ancient civilizations. The Earth eats its own history. Subduction zones pull ocean floor down into the mantle, like a conveyor belt feeding a furnace. Metamorphism transforms one type of rock into another, cooking away the details. Erosion carries mountains to the sea one grain of sand at a time. The geological record that we rely on to understand the past is not a complete archive. It's more like a book where 90% of the pages have been torn out, burned, and replaced with blank paper. You try to do the math in your head, but the numbers are slippery. Earth is 4.5 billion years old. The oldest rocks we've ever found on the surface date back about 4 billion years, and they're rare. Most surface rocks are much younger. The oldest ocean floor is only about 200 million years old, because everything older than that has already been recycled through the mantle. So if an industrial civilization existed, say 300 million years ago, any evidence on the ocean floor would be long gone. And evidence on land? Well, that depends on where the land was and what happened to it since. Scholars still debate whether the fossil record represents even 1% of all species that ever lived. The conditions for fossilization are so specific. You need rapid burial, the right minerals, protection from scavengers and bacteria, that the vast majority of creatures that ever existed left no trace at all. Soft bodies, delicate structures, anything organic simply vanishes. And artifacts? Tools made of wood or leather or plant fibre, forget it. They'd be lucky to last a few centuries, let alone a few epochs. You think about this as you drift through imaginary millennia, watching landscapes transform beneath you like time-lapse photography, taken by a very patient and somewhat bored god. A river carves a canyon. A glacier grinds a valley flat. A volcano buries an entire region under ash that will eventually become fertile soil that will eventually erode into the sea. Everything moves, everything changes, everything is eventually unmade. Here's a quirky little detail that might keep you company as you fall asleep. Scientists estimate that the total mass of all living things that have ever existed on Earth, if you could pile them all up, would be equivalent to a layer of organic material about 10 meters thick covering the entire planet. 10 meters. That's the sum total of 4 billion years of life. All the dinosaurs, all the trilobites, all the forests and bacteria, and weird Cambrian monsters. And that 10-meter layer has been processed and recycled so many times that almost nothing original remains. You're made of recycled atoms. So was everything that came before you. So will be everything that comes after. The implication settles over you like a warm blanket. If an ancient civilization existed, their bodies and their buildings and their dreams have been recycled too. The carbon in your lungs might once have been part of a temple wall. The calcium in your bones might once have been a monument to a forgotten king. You can't know, and that's the point. Deep time doesn't keep receipts. But here's where it gets interesting, and Schmidt and Frank understood this. Some things do survive. Not many things, not most things, but some. Certain synthetic materials that don't occur naturally could persist in sedimentary rocks as chemical anomalies. Radioactive isotopes with long half-lives could leave detectable signatures. A sudden spike in carbon dioxide from burning fossil fuels could appear in ice cores or limestone as an unexplained blip. These are the fingerprints that an industrial civilization might leave behind, even after everything else is gone. You imagine future geologists millions of years from now, drilling core samples from ancient rock and finding something strange. A layer with too much lead maybe, or an inexplicable concentration of synthetic polymers. They wouldn't know what to make of it. They'd argue about contamination, about volcanic outgassing, about every possible natural explanation before entertaining the idea that someone was here before them, because that's how science works. You exhaust the boring explanations before you reach for the wild ones. The thing about deep time is that it's humbling without being cruel. It doesn't mock you for your smallness. It simply is what it is. A vast, slow, patient force that treats all things equally. Your greatest achievements and your most embarrassing moments will receive the same treatment. Dissolution, transformation, return. The Silurian Hypothesis asks us to consider that this process might have happened before, that intelligence might have flickered to life and then been gently, thoroughly extinguished by the same forces that will one day extinguish us. You're not frightened by this. How could you be? The pillow is too soft, the room is too dark, and the idea is too large to fit inside your tired brain all at once. Instead, you let it exist at the edges of your awareness, a gentle hum of cosmic perspective that makes your own worries seem wonderfully, refreshingly small. The Earth has been erasing things for billions of years. It's very good at its job, and somehow, against all odds, you're still here, thinking about it, which is itself a kind of miracle. You drift now from the abstract to the concrete, from the vast machinery of planetary recycling to a single focused question. What would actually survive? If you wanted to leave a message for the far future, a calling card that said, "We were here," what would you choose? And more importantly, what would you have to avoid choosing? Because the universe is remarkably efficient at destroying things you care about. Let's start with the obvious candidates. Plastic. That miracle material that we've been scattering across the planet like confetti at a particularly careless wedding. Surely plastic would survive, right? It takes hundreds of years to break down in the environment. Your great-great-grandchildren's great-great-grandchildren will still be finding bottle caps on beaches. But here's the thing. Hundreds of years is nothing on geological timescales. 1,000,000 years from now, even the sturdiest plastics will have degraded into microscopic fragments, and those fragments will have been scattered and diluted until they're just a faint chemical signature in the rock. Detectable maybe, if you know what to look for, but not exactly a smoking gun. What about metal? The great iron and steel skeletons of our cities, the bridges and skyscrapers and railroad tracks that we're so proud of? Iron rusts, steel corrodes. Given enough time, and remember, we're talking about millions of years here. Even the most massive structures will oxidize and crumble and be absorbed back into the earth. Archaeologists have trouble finding iron artifacts from just a few thousand years ago because metal doesn't like to stay metal. It wants to return to ore, to rust, to the stable embrace of oxide compounds. Your smartphone, that gleaming rectangle of technological achievement, would be an unrecognizable smear of corroded elements before the next ice age is finished. Historians still argue whether any human-made object could survive intact for more than a few million years, and the consensus seems to be, probably not. The forces of erosion, oxidation, and geological transformation are simply too powerful. Even the most durable materials we can create, tungsten perhaps, or certain ceramics, would eventually be ground down, melted, or subducted. The Earth is not a museum. It's a recycling centre with a very aggressive timeline. But survival doesn't have to mean intact. It can mean detectable, and that's a different standard entirely. Consider radioactive isotopes. When we split atoms and build nuclear reactors and test weapons, we create elements that don't exist naturally in significant quantities. Plutonium-244, for example, has a half-life of about 80 million years. If an ancient civilization went through a nuclear phase, and that's a big if, but stay with me here, traces of their atomic adventures might still be lingering in the geological record, waiting for a sufficiently clever geologist to notice. You picture a future scientist, not human maybe, but something that inherited the Earth after we were gone, bent over a mass spectrometer, frowning at unexpected readings. Too much plutonium here, too much uranium-235 there. They run the numbers again and again, checking for contamination, for natural explanations, for anything that would make the anomaly go away. But it doesn't go away, and eventually, reluctantly, they begin to entertain the impossible. Someone was here before. Here's a quirky detail for your drifting mind. One of the most durable markers of our civilization might be chicken bones. We've raised so many chickens, about 23 billion alive at any given moment, that their bones have become a defining feature of the geological layer we're currently creating. Future paleontologists might call this the Chickenocene. They'll dig through our strata and find layer after layer of chicken remains, more chickens than any natural ecosystem could possibly support, and they'll know that something very strange happened here. Not necessarily something intelligent, mind you, just something very, very weird. The carbon signature is another avenue of detection. When you burn fossil fuels, you're releasing carbon that's been locked away for millions of years, carbon that has a distinctive isotopic signature because it's depleted in carbon-14. This creates a measurable blip in the geological record, a sudden shift in the ratio of carbon isotopes that can't be explained by natural processes. We've already created such a blip. It started around 1850 and has been accelerating ever since. If someone looks at the rocks 50 million years from now, they'll see it. A sharp spike that coincides with a mass extinction, a temperature surge, and an unprecedented accumulation of synthetic materials. You lie there in the darkness, thinking about the future archaeologists sifting through the rubble of your world. What will they conclude? that you were wise or foolish, advanced or primitive, worthy of remembrance or just another failed experiment in the long history of Earth's attempts to produce something interesting. You don't know. You can't know. All you know is that you're here now, leaving your marks on the planet whether you mean to or not, and someday, maybe soon by geological standards, those marks will be all that remains. The thought is neither comforting nor distressing. It simply is. You exist in this moment, breathing air that has been breathed by countless creatures before you, sleeping on a planet that has witnessed more beginnings and endings than you can possibly count. And in that context, the question of whether we're the first civilization stops feeling like a mystery and starts feeling like a meditation. You don't need to solve it, you just need to sit with it. Let it soften the edges of your consciousness and drift. The timeline shifts beneath you now, pulling you backward through epochs you only half remember from school, past the asteroid that killed the dinosaurs, past the first flowers and the first mammals, past continental configurations that would make a modern map completely useless. You land softly in the Carboniferous period, about 300 million years ago, and immediately you notice something strange about the air. It's thick, it's rich. It tastes like oxygen because that's exactly what it is. Oxygen levels nearly 50% higher than what you're used to breathing. Your lungs feel like they're getting a bonus with every breath, which is great for you, but even better for the creatures that lived here. Because in a world with more oxygen, things can grow bigger. Much bigger. You see the dragonflies first. Except dragonflies is a generous term for what's buzzing through these swampy forests. Meganeura, they're called, and their wingspan is about 75 centimeters. That's roughly the size of a seagull, except it's a dragonfly, and it's hunting smaller insects with the ruthless efficiency of something that has never needed to evolve caution. The giant millipedes come next, Arthropleura, as long as a car, scuttling through the undergrowth on too many legs. The forests themselves are alien, towering club mosses and tree ferns creating a canopy so dense that the sun barely reaches the ground. This is the world that would eventually become your coal. The plants grew so prolifically, and the bacteria that decompose plants hadn't fully evolved yet, so when trees died, they just piled up. Layer after layer, year after million years, compressed and heated until they became the black rocks that would power your industrial revolution 300 million years later. You find this darkly amusing. The Carboniferous period spent eons storing energy, and you've spent 3 centuries burning through it as fast as possible. But here's the question that hums at the edges of your sleepy mind. Could something intelligent have emerged here? The oxygen level supported larger brains, at least theoretically. There were complex ecosystems, competition, predation, all the pressures that supposedly drive the evolution of intelligence. And 300 million years is a long time. Long enough for intelligence to arise, flourish, and be completely erased by everything that came after. Scholars still debate whether intelligence requires specific conditions that weren't present in the Carboniferous. The dominant land animals were amphibians and early reptiles, creatures with relatively simple nervous systems. There were no primates, no mammals at all, nothing with the particular neurological architecture that we associate with complex thought. But then again, we only have one example of intelligence evolving, ourselves, and we have no idea how necessary our particular path was. Maybe intelligence could arise in a giant amphibian just as easily as in a primate. We literally don't know. Here's a quirky little fact to carry with you into your dreams. There's a hypothesis, not widely accepted but genuinely proposed, that the Carboniferous period's extreme oxygen levels could have supported fire-based technology. Fire burns better in oxygen-rich environments. Much better, in fact. A Carboniferous civilization, if one existed, might have had access to metallurgy and combustion that we can barely imagine. They could have smelted metals that we struggle to work with, built engines that we couldn't replicate, and then they could have burned themselves out of existence, consuming the very atmosphere that made their achievements possible. You imagine it, a race of intelligent amphibians glistening in the perpetual twilight of the swamp forests, tending furnaces that burn with unnatural intensity. They build, they expand, they flourish, and then the oxygen levels drop, not through any fault of their own necessarily, but through the slow geological processes that always win in the end. Their fires grow harder to sustain, their industry falters, and without the energy surplus that made their civilization possible, they fade, leaving behind nothing but puzzling isotope ratios and unexplained mineral deposits that no one will discover for another 300 million years. Of course, there's no evidence for any of this. That's the point. The Carboniferous is so far back in the geological record that even finding dinosaur bones from that era is impossible. Dinosaurs didn't exist yet. Any artifacts, any structures, any trace of civilized activity would have been compressed, heated, transformed, and ultimately absorbed into the coal seams that we've since been burning. You might be releasing their carbon right now every time you turn on a light or charge your phone. Their atoms might be mixing with your atoms, a reunion 300 million years in the making. The swamp around you grows quieter as you settle deeper into contemplation. The giant dragonflies buzz past without noticing you, because you're not really here. You're just visiting, a consciousness drifting through possibilities. The Carboniferous doesn't answer your questions. It just offers more room for wondering, more space for the imagination to play. Maybe there was nothing here but ferns and insects and the slow accumulation of future fuel. Or maybe there was something more, something that lived and loved and wondered just like you and was erased so thoroughly that even the question of its existence seems absurd. You don't need to decide tonight. The mystery is a gift, not a burden. You can hold it loosely. Let it drift alongside you as your breathing slows and your thoughts grow fuzzy at the edges. The Carboniferous is patient. It's been waiting 300 million years. It can wait a little longer while you sleep. You leave the swamps behind and travel forward through time, past mass extinctions and continental reshufflings, until you arrive at a world that feels slightly more familiar. This is the Mesozoic, the age of reptiles, and you've entered the longest single chapter in the story of complex life on land. The dinosaurs have arrived, and they're planning to stay for a while. 165 million years. Let that number wash over you as you lie there in the darkness, because it's hard to comprehend without some context. Modern humans have existed for about 300,000 years. All of recorded human history fits into the last 5,000 years or so. The dinosaurs dominated this planet for 165 million years. That's enough time for evolution to run thousands of experiments, for species to rise and fall and rise again, for intelligence to emerge and vanish multiple times over without leaving any trace we would recognize. You watch them now, these magnificent creatures, in all their bewildering variety. The long-necked sauropods browsing treetops like living cranes, the armored ankylosaurs trundling through underbrush, built like tanks made of bone, the tyrannosaurs obviously, because everyone loves a good apex predator, but also the small ones, the clever ones, the dinosaurs that paleontologists don't put on lunchboxes because they're not photogenic enough. These are the ones that interest you tonight. Because here's the thing about intelligence. It doesn't evolve in a vacuum. It evolves in response to specific pressures, complex social environments, the need for problem solving, competition for resources. And the Mesozoic had all of these things in abundance. There were dinosaurs that lived in herds, dinosaurs that raised their young cooperatively, dinosaurs that hunted in packs using coordinated strategies. The building blocks for intelligence were there. The time was certainly there. So why didn't it happen? Historians still argue whether the dinosaurian body plan was fundamentally incompatible with technological civilization. The traditional answer is that dinosaurs were cognitively limited. Their brains, relative to body size, were smaller than mammalian brains, and brain size correlates roughly with intelligence. But this explanation feels too convenient, too comfortable. It assumes that our particular path to intelligence was the only possible path, that you need a primate-sized brain in a primate-shaped body to build cities and write poetry. Here's where things get wonderfully weird. There were dinosaurs with relatively large brains. Troodon, which we'll meet properly in the next section, had a brain-to-body ratio comparable to modern birds, and modern birds, particularly corvids and parrots, are shockingly intelligent. They use tools, they solve complex problems, they recognize themselves in mirrors. If birds can do this with dinosaurian neural architecture, why couldn't a dinosaur 70 million years ago have done something similar? The quirky detail for tonight is this. We actually have no idea what dinosaur behavior was really like. Fossils preserve bones, not brains. They preserve anatomy, not culture. A dinosaur could have been painting cave art and performing ritual dances and telling stories around fires, metaphorical fires, since they probably couldn't control actual flames, and we would never know. The fossil record shows us bodies. It doesn't show us minds. You try to imagine a dinosaurian civilization, and your brain struggles with the imagery. What would their cities look like? Would they have cities at all, or would their societies be organised along completely different lines? Maybe they were nomadic, following the great herds of herbivores across continents that no longer exist. Maybe they lived in the trees, or in elaborate burrow systems, or in places we've never thought to look because our ideas about civilization are too limited. The truth is, we don't know what we don't know. We assume dinosaurs were non-intelligent because they left no evidence of intelligence. But as we've already established, evidence has a way of disappearing. 165 million years is long enough for any artifact, any structure, any trace of civilized activity to be utterly erased. If a dinosaur species developed technology and culture 100 million years ago, and if that culture lasted for a mere 10,000 years before collapsing, a shorter run than our own civilization has had, what would remain? Nothing. Absolutely nothing that we would recognize. The asteroid that ended the Mesozoic hit 66 million years ago, and it was thorough. It killed about 75% of all species on Earth, including every non-avian dinosaur, but 66 million years is only the end of the story, not the whole story. There were 99 million years before that impact, 99 million years during which dinosaurs could have been doing something more interesting than we give them credit for. We assume they weren't, but we don't actually know. You let the dinosaurs fade back into their deep past, carrying their secrets with them. The question of dinosaurian intelligence might never be answered, and that's okay. Some mysteries are valuable precisely because they can't be solved. They keep us humble, remind us that the universe is under no obligation to reveal all its secrets. You are the descendant of the tiny mammals that scurried underfoot while the dinosaurs ruled, and now you're lying in a warm bed, contemplating whether your evolutionary predecessors might have had predecessors of their own. The irony isn't lost on you, but it doesn't keep you awake. You've been hearing whispers about Troodon all evening, catching glimpses of this strange creature at the edges of your awareness. Now it's time to meet it properly, to sit with the dinosaur that sparked 1,000 speculative conversations about what might have been. Troodon was not particularly large, about 2 meters from nose to tail, roughly the size of a big dog if that dog were stretched out and given a long, stiff tail for balance. It lived during the late Cretaceous, about 77 million years ago, stalking the forests and plains of what would eventually become North America. But what made Troodon special wasn't its size or its speed or its hunting techniques. What made Troodon special was its brain. Relative to its body mass, Troodon had one of the largest brains of any dinosaur. Its encephalization quotient, that's the fancy term for brain-to-body ratio, was comparable to modern birds and some early mammals. More importantly, Troodon had forward-facing eyes, which suggest binocular vision and depth perception. It had manipulative hands with partially opposable digits, which suggest the ability to grasp and potentially use tools. And it had large, expressive eyes that have led some paleontologists to speculate it was nocturnal or crepuscular, hunting in low-light conditions where intelligence and sensory acuity would provide a significant advantage. In 1982, a paleontologist named Dale Russell did something unusual. He asked a simple question. If Troodon hadn't gone extinct, what might it have evolved into? And then he tried to answer that question by constructing a hypothetical descendant, a creature he called the dinosauroid. The result was, well, controversial is a polite word for it. Russell's dinosauroid looked unsettlingly human, bipedal, upright, with a rounded skull to house an enlarged brain, and a body plan that wouldn't look out of place in a science fiction movie. Critics immediately pointed out that this was probably anthropocentric bias at work. There's no reason an intelligent dinosaur would need to look like us. Intelligence can take many forms, and our particular body plan is just one solution to the problem of being smart. Scholars still debate whether Russell's thought experiment was brilliant or misguided, visionary or embarrassingly naive. The dinosauroid has become something of a meme in paleontological circles, trotted out whenever someone wants to make a point about the limits of speculation. But underneath the mockery, there's a genuine question that refuses to go away. Why didn't it happen? Here's the quirky detail that will follow you into your dreams. Troodon's eggs have been found in nests arranged in careful rings, suggesting parental care and possibly cooperative breeding. Some researchers believe Troodon may have exhibited social behaviours comparable to modern birds, which are themselves descended from dinosaurs. Social behaviour plus large brains plus manipulative hands. That's the recipe for intelligence. We see it in primates, in cetaceans, in corvids. Why not in dinosaurs? The honest answer is that we don't know. Evolution is not a ladder leading inevitably toward intelligence. It's a bush, branching in countless directions, and intelligence is just one branch among many. Troodon didn't evolve toward greater intelligence for the same reason that most species don't. There was no selective pressure pushing in that direction. It was smart enough to survive in its environment. That was enough. Evolution doesn't reward potential, it rewards adequacy. But you're lying in bed now, drifting towards sleep, and adequacy isn't very interesting. Potential is interesting. What ifs are interesting. So you let yourself imagine a different timeline, one where the asteroid missed, where Troodon kept evolving, where 77 million years of natural selection pushed those already impressive brains towards something remarkable. You picture them, the troodontids, let's call them, learning to make tools from wood and bone. Not metal, not yet, but tools nonetheless. You picture them developing language, or something like language, communication complex enough to share ideas across generations. You picture them building shelters, controlling fire, eventually, creating art. You picture them gazing up at the stars and wondering, just like you're wondering now, whether they're alone in the universe, and then you picture them vanishing. Because every civilization, every species, every individual vanishes eventually. Maybe the asteroid still came, just later. Maybe climate change caught them off guard. Maybe they consumed their resources and collapsed under the weight of their own success. The how doesn't matter as much as the that. The recognition that even if they existed, they're gone now, leaving nothing but the faintest chemical signatures in rocks that have been transformed beyond recognition. You find this oddly comforting. The troodontids, if they existed, worried about things. They had problems to solve, challenges to overcome, fears to face. And those worries, those problems, those fears, they're gone too. The universe has forgotten them so completely that we're not even sure there's anything to forget. And someday, the universe will forget you just as thoroughly. This is not a tragedy, it's just the way things are. The forgetting is part of the deal. The Troodon fades back into the late Cretaceous, taking its mysterious potential with it. You'll never know what it could have become, but then again, Troodon never knew what you would become either, and that seems fair. The past looks forward with the same blindness that the future looks backward. You're all in this together, connected by atoms and time and the endless recycling of matter through the patient machinery of the planet. You emerge from the Mesozoic into more recent territory, though recent is a relative term when you're swimming through deep time. The dinosaurs are gone now, or rather most of them are gone. The birds remember, and you find yourself in a strange new world. This is the world of human archaeology, of artifacts and enigmas, of objects that shouldn't be where they are or when they are. The term is UPART, which stands for Out of Place Artifact. It's not a scientific term exactly. Mainstream archaeologists tend to avoid it because it carries too much baggage from ancient astronaut theories and conspiracy documentaries. But the concept itself is legitimate. Sometimes we find things that challenge our understanding of what was possible in a given time or place. Sometimes those challenges lead to genuine revisions of history, and sometimes they're just hoaxes, or misinterpretations, or honest mistakes made by well-meaning amateurs. You encounter the Antikythera mechanism first, because it's the most famous and the least controversial. In 1901, divers exploring a Roman-era shipwreck off the coast of Greece discovered a corroded lump of bronze that turned out to be the most sophisticated piece of technology ever found from the ancient world. It's a mechanical computer, essentially, designed to predict astronomical positions, eclipses, and even the timing of the Olympic Games. It dates to around 100 BCE, which means someone in the ancient Mediterranean had knowledge of gearing and precision engineering that wouldn't be replicated in Europe for another 1,000 years. The Antikythera mechanism isn't evidence of a pre-human civilization. It's clearly Greek, clearly Roman era, clearly the product of a known historical culture. But it's humbling nonetheless, because it reminds us how much we've lost. If this device existed, what else existed that we haven't found? What books have rotted? What machines have rusted? What entire fields of knowledge have simply evaporated because nobody thought to write them down, or the writing has been destroyed, or we haven't excavated the right ruin yet? Scholars still debate how much ancient technology we've failed to recover, and the estimates range from most of it to almost all of it. The Library of Alexandria burned. The Baghdad House of Wisdom was sacked. The oral traditions of countless cultures were lost when their speakers died or were killed. We know only what survived, and survival is not a reliable sampling method. But you're here for the weirder stuff, aren't you? The objects that might, emphasis on might, hint at something even stranger than forgotten Greek engineering. So let's talk about some of them, with appropriate skepticism mixed in. The Dorchester pot is a bell-shaped metal vessel allegedly found inside solid rock during blasting operations in Massachusetts in 1852. If genuine, it would suggest metalworking before the continent was even colonized, but the documentation is sketchy. The original artifact is lost and the story has all the hallmarks of a Victorian-era hoax or misidentification. The quirky detail here is that 19th century newspapers loved these stories, the weirder the better, and rarely bothered with fact-checking. The so-called ancient battery discovered near Baghdad is more interesting. It's a clay jar containing a copper cylinder and an iron rod, and if you fill it with an acidic solution, it can indeed produce a small electrical current. Some researchers suggest it was used for electroplating jewellery. Others think it was purely ritual, the metal arrangement coincidental. We don't know, and we probably never will, because the artifact was looted during the 2003 invasion, and its current whereabouts are unknown. Then there are the alleged hammers embedded in coal or rock, the London hammer, the King Goody hammer, which surface periodically in creationist literature as evidence that the geological timescale is wrong. The problem is that none of these artifacts have been rigorously studied under controlled conditions. Concretions can form around modern objects surprisingly quickly. Miners sometimes lose tools that get incorporated into later geological formations. Extraordinary claims require extraordinary evidence, and the evidence here is decidedly ordinary. You let these objects drift through your consciousness without grasping too tightly at any of them. The world is full of puzzles, and not every puzzle has a solution that rewrites history. Most of them have boring explanations involving hoaxes, contamination, or wishful thinking. But a few, a precious few, remain genuinely unexplained, hovering at the edges of mainstream archaeology like ghosts at a dinner party. The Antikythera mechanism reminds you that the past was more sophisticated than we often assume. The U-parts, even the fake ones, remind you that humans have always been hungry for mysteries, always eager to believe that there's more to history than the textbooks contain. And maybe there is. Maybe somewhere, in some unstudied rock formation or unexcavated ruin, there's something that would change everything we think we know. Or maybe not. Maybe we're just pattern-seeking animals, finding faces in clouds and civilizations in coincidences. Either way, it's a good thought to fall asleep to. The past is bigger than we know. The universe is stranger than we admit, and you're here now, wondering about it all, which is itself a kind of miracle. The U-parts fade into the background, replaced by something more solid, more undeniably real. You're standing now on a hilltop in southeastern Turkey. The year is 1994, and a German archaeologist named Klaus Schmidt has just had his worldview shattered. He's staring at a collection of carved stone pillars that have no business being here. Because according to everything he knows about human history, the people who lived here 12,000 years ago shouldn't have been able to build them. This is Göbekli Tepe, and it changes everything. The pillars are massive. Some of them stand over 5 meters tall and weigh more than 10 tons. They're arranged in circles, T-shaped and covered with intricate carvings of animals. Lions, foxes, scorpions, snakes, vultures. The workmanship is sophisticated, the engineering impressive, and the dating is unambiguous. These structures are about 11,600 years old, which means they were built before pottery, before metallurgy, before writing, before, and this is the crucial part, before agriculture. You've probably heard the story of civilization 1,000 times. It goes like this. First, humans invented farming. Farming created food surpluses. Food surpluses freed up time and labour for specialised tasks. Specialisation led to cities, governments, organised religion, monumental architecture. This is the Neolithic Revolution, the foundation of everything that came after. Except Göbekli Tepe doesn't fit. The people who built these temples weren't farmers. They were hunter-gatherers, the kind of people we've always assumed were too busy surviving to build anything permanent. Scholars still debate whether Göbekli Tepe was a temple, a gathering place, a pilgrimage site, or something else entirely. The current theory is that it was a ritual centre, a place where scattered bands of hunters came together for religious ceremonies and communal feasting. Animal bones found at the site suggest massive barbecues, hundreds of people eating together, sharing food and stories and whatever beliefs the pillars were meant to represent. And when the ceremonies were over, they buried the pillars deliberately, filling in the circles with dirt and rubble, perhaps to sanctify them, or perhaps to start fresh with new construction. Here's the quirky detail that keeps archaeologists up at night. we still don't know where these people came from or what they knew. Göbekli Tepe appears suddenly in the archaeological record, already sophisticated, already impressive. There's no clear developmental sequence leading up to it, no trail of simpler structures that would show us how these techniques were learned. It's as if the builders already knew what they were doing, already possessed knowledge that they had acquired somewhere else, at some earlier time, in some place we haven't found yet. This is where the speculation gets interesting. What if Göbekli Tepe wasn't the beginning of something but the end? What if it represents the last gasp of a more developed culture, survivors carrying forward traditions from a civilization that no longer exists? The mainstream archaeological response is that we simply haven't found the developmental stages yet, that there are earlier sites waiting to be discovered. And that's probably true, but the absence of those sites so far leaves room for wondering. The site was deliberately buried around 10,000 years ago, and then it was forgotten. For 10,000 years, people lived and died and built new civilizations within walking distance, and nobody knew that these massive stone circles lay just beneath the surface. If Schmidt hadn't noticed some carved stones sticking out of a hillside, they might still be hidden, and that raises an uncomfortable question. What else is hidden? How many Göbekli Tepes are lying undiscovered beneath farmland and cities and desert sands, their secrets unguessed, their builders unknown? You wander among the pillars now, running your fingers across carvings that predate the pyramids by 7,000 years. The animals stare back at you with expressions that might be sacred or might be decorative. You can't tell, and neither can the experts. The fox looks smug. The vulture looks patient. The serpents coil around the edges of the stone, frozen mid-slither for 11 millennia and counting. The people who made these carvings had names. They had families, hopes, fears. They told jokes and argued about petty things and probably complained about their backs hurting from all the heavy lifting. They were as fully human as you are, and yet we know almost nothing about them. Not even their names for themselves, because they had no writing. Or if they did, it hasn't survived. Göbekli Tepe doesn't prove that pre-human civilizations existed, but it proves something almost as unsettling. Human civilizations can exist and be completely forgotten for thousands of years, even when they are built from massive, enduring stone. If that can happen in the last 12 millennia, what might have happened in the 12 million before that? Or the 100 million? The mind starts to spin, and you let it spin. Because spinning is a kind of lullaby when you're this tired. You leave the stone circles of Turkey and follow the water down through rivers and aquifers, and eventually into the sea itself. Because if ancient civilizations existed and were forgotten, where better to hide them than beneath the waves? The ocean covers 70% of the planet's surface, and we've explored less of it than we've explored the moon. The flood myths come first, dozens of them, hundreds of them, from cultures that had no contact with each other, all telling variations of the same story. The waters rose, the world was drowned, a chosen few survived to begin again. You've heard of Noah, of course, but you might not know about Manu from Hindu tradition, or Deucalion from Greek mythology, or Utnapishtim from the Epic of Gilgamesh, which predates the Hebrew Bible by at least 1,000 years. The indigenous peoples of North America have flood stories. So do the Aboriginal Australians. So do isolated tribes in South America and Southeast Asia, and everywhere else we've bothered to ask. Scholars still debate whether these myths share a common origin, or arose independently from local floods that seemed world-ending to the people who experienced them. The end of the last ice age, about 11,700 years ago, caused sea levels to rise dramatically, over 120 metres in some estimates, though the rise happened over thousands of years rather than all at once. Entire coastlines were swallowed. The land bridge between Asia and North America flooded to become the Bering Strait. The Mediterranean broke through the Bosphorus and may have catastrophically flooded the Black Sea basin. It's plausible that these events were remembered, passed down through oral tradition, and eventually crystallized into the flood myths we know today. But here's where it gets interesting. If the coastlines were flooded, what was on them before the water came? Early humans, like modern humans, tended to settle near water sources. Rivers, lakes, and especially coastlines were prime real estate. Easy access to fish, trade routes, fresh water, fertile land. The villages and cities that would have been most populated, most sophisticated, most likely to leave evidence of civilization, would have been exactly the places that are now underwater. You dive now, metaphorically, following the drowned landscapes down into the darkness. Off the coast of India, there are submerged structures near the town of Dwarka that Hindu tradition identifies as the legendary city of Lord Krishna, swallowed by the sea 5,000 years ago. Near Yonaguni Island in Japan, divers have found massive stone formations that look like stepped pyramids and paved streets, though whether they're natural or artificial remains hotly contested. In the Mediterranean, archaeologists have found Bronze Age cities beneath the waves, complete with streets and buildings and artifacts that tell stories of people who thought their homes were permanent. The quirky detail for tonight: the ancient port of Heraklion, also known as Thonis, was a thriving Egyptian city that sank into the Mediterranean about 2,200 years ago. For centuries it was considered legendary, mentioned in Greek texts but never found. Then, in 2000, underwater archaeologists discovered it sitting on the seafloor near Alexandria, remarkably preserved by the mud and salt water. Gold coins, massive statues, stone inscriptions, all just waiting to be found. If a major city can be lost for 2 millennia and then casually rediscovered, what else might be down there? You float now through hypothetical ruins, imagining what might have been. Maybe there were cities along the drowned coastlines that we'll never find, their wooden structures long rotted, their stone foundations scattered by currents and covered by sediment. Maybe the great civilizations of the Ice Age weren't in the places we've been excavating, but in the places that are now continental shelves, inaccessible beneath 50 meters of cold, dark water. The ocean doesn't give up its secrets easily. Underwater archaeology is expensive, dangerous, and limited by visibility, currents, and the crushing pressure of depth. We've mapped more of Mars than we've mapped our own ocean floor, and the deeper you go, the less survives. Organic materials decay, metals corrode, even stone is eroded by the relentless patience of salt water. Whatever was down there 12,000 years ago, whatever achievements and dreams and art existed on those drowned coastlines, most of it is probably gone forever. But not all of it. That's the tantalizing thing. Every few years, divers find something new, a submerged site, an unexpected artifact, a hint that the past was stranger and more complicated than we assumed. The Yonaguni Monument, whatever it is, reminds us that the Earth still has secrets. The ruins of Dwarka remind us that myths sometimes point toward real places. And the flood stories, whispered across cultures and continents, remind us that the ocean once took something from humanity, something important enough to be remembered for 11,000 years. You let yourself sink deeper into the comfortable darkness of almost sleep, feeling the weight of all that water pressing down on all those mysteries. The sea keeps its own counsel. It doesn't care about your questions. But somehow that makes it easier to rest, knowing that the universe is bigger and wetter and stranger than you'll ever fully understand. You rise from the depths and keep moving south, past the temperate zones, past the tropics, toward a continent that sits alone at the bottom of the world, wrapped in ice and silence. This is Antarctica, and it's been waiting for you. Today, Antarctica is the coldest, driest, windiest continent on Earth. Average winter temperatures at the South Pole hover around -50 degrees Celsius. The ice sheet covering the landmass is nearly 5 kilometers thick in some places, containing about 70% of all the fresh water on the planet. Nothing lives in the interior except extremophile bacteria and the occasional confused scientist. It is, by any reasonable measure, the last place you'd expect to find evidence of civilization. But Antarctica hasn't always been this way. Rewind the clock 50 million years to the Eocene epoch, and the continent looks completely different. It's still at the South Pole, the plate tectonics have it pinned there. But there's no ice. Instead, there are forests. Lush, temperate forests filled with southern beech trees, conifers, and ferns. The climate is mild, something like modern-day New Zealand or Tasmania. Animals roam the landscape. Ancient marsupials, strange ungulates, early penguins that haven't yet figured out they can't fly. Scholars still debate exactly when Antarctica froze over, but the transition began roughly 34 million years ago, when the continent separated from South America and the circumpolar current formed, isolating Antarctica from warmer waters to the north. The cooling was gradual at first, then accelerated. By about 14 million years ago, the ice sheet was essentially permanent, and once the ice came, it stayed, burying the continent under a frozen blanket that's still there today. Here's the thing about that ice. It's opaque. We can't see through it, and we can't dig through it, not in any meaningful way. What lies beneath is essentially unknown, accessible only through ice-penetrating radar and occasional drilling projects that can only sample tiny pinpricks of the vast landscape. And what the radar has revealed is tantalizing. Beneath the ice, there are mountains, valleys, rivers, and lakes, an entire topography, frozen in time, waiting for a thaw that may never come. The quirky detail for tonight. In 2017, researchers announced the discovery of a massive volcanic system beneath the West Antarctic ice sheet, over 90 volcanoes hidden under the ice. Some of them are active, generating enough heat to melt the ice from below and create subglacial lakes of liquid water. These lakes, there are over 400 of them that we know of, are completely isolated from the outside world, containing water that hasn't seen sunlight in millions of years. What lives in them? What might have lived in them long ago? We have no idea. Fringe theories about Antarctica are as old as the continent's exploration. Some people claim that ancient maps show an ice-free Antarctica, suggesting that someone mapped it before the freeze. Others propose that a lost civilization once flourished there, its ruins now buried under kilometers of ice. The mainstream scientific response to these claims ranges from gentle skepticism to outright dismissal. The evidence for an Antarctic civilization is essentially non-existent. No artifacts, no ruins, no anomalous signals in the ice cores that we've managed to drill. But here's the uncomfortable truth. Absence of evidence is not evidence of absence, especially when the evidence would be buried under 5 kilometers of ice. We cannot prove that there was no Antarctic civilization because we cannot examine Antarctica in any meaningful way. The ice is too thick, too cold, too hostile. Whatever lies beneath, fossils, artifacts, empty rock, nothing at all, will remain hidden until the ice melts, which may not happen for millions of years, if ever. You imagine it now, because imagining is free and the night is long. A temperate Antarctica 40 million years ago, covered in forests and populated by creatures we've never discovered. Maybe one of those creatures was intelligent. Maybe it built structures from wood that have long since rotted, leaving no trace in the fossil record. Maybe it lived and died and was buried under the advancing ice, its civilization compressed into a thin layer of sediment that future geologists will never reach. Or maybe not. Maybe Antarctica was always just a continent of trees and animals, pretty but unremarkable, its history exactly as boring as the mainstream narrative suggests. You have no way of knowing, and neither does anyone else. the ice keeps its secrets, and you're too tired to demand answers. You let Antarctica fade back into the white silence, feeling strangely comforted by its impenetrability. Some mysteries are meant to stay mysterious. Some doors are meant to stay closed, not because of what's behind them, but because the act of wondering is itself worthwhile. You don't need to know what's under the ice. You just need to know that there's something you don't know, and that's enough to make the universe feel vast and strange and beautiful. You stay in the vicinity of maps and ancient knowledge, because the Antarctica speculation naturally leads to one of the most controversial documents in the history of cartography. The year is 1513. The place is Constantinople, or Istanbul, depending on who you ask. And an Ottoman admiral named Piri Reis is about to create something that will puzzle historians for centuries. The Piri Reis map is a fragment, actually. Only about a third of the original survives, drawn on gazelle skin parchment. What remains shows the western coast of Africa, the eastern coast of South America, and, in the lower right corner, something that has generated more arguments than a holiday dinner with extended family. It appears to show a landmass stretching south from the tip of South America, and some researchers claim it depicts the Antarctic coastline, the actual coastline under the ice. Now here's why this is strange. Modern humans didn't discover Antarctica until 1820, and we didn't map the coastline under the ice until the 1950s, using seismic surveys. If the Piri Reis map really shows an ice-free Antarctica, that would mean someone mapped it before the freeze, which ended 14 million years ago, or they had access to maps from someone who did. That's a big if, and we should treat it with appropriate skepticism. Scholars still debate whether the southern landmass on the Piri Reis map is actually Antarctica at all. The shape is roughly correct in some places, and wildly wrong in others. The scale is inconsistent. The islands don't match up. Many historians believe the landmass is simply Terra Australis Incognita, the hypothetical southern continent that European mapmakers had been including on their charts for centuries, based on the assumption that there must be a large landmass in the south to balance the northern continents. It might not be a map of Antarctica at all, just a guess that happened to be in the right general location. But Piri Reis himself added a note to the map that has fueled endless speculation. He wrote that he compiled the map from about 20 source charts, including some that dated back to the time of Alexander the Great and possibly earlier. These source maps, if they existed, have never been found. We have only Piri Reis's claim that they existed, which is not exactly airtight evidence. Here's the quirky detail that makes this case so fascinating. The Piri Reis map isn't alone. There are other historical maps, the Orontius Phineus map of 1531, the Mercator map of 1569, that also appear to show an ice-free Antarctic coastline, or at least something that can be interpreted that way if you squint hard enough. The question is whether these maps represent genuine ancient knowledge, passed down through copies and translations across millennia, or whether they're simply imaginative guesses by cartographers who like to fill in blank spaces. The proponents of the ancient knowledge theory, and there are more of them than you might expect, though mainstream academia remains skeptical, argue that the maps demonstrate the existence of a sophisticated civilization with advanced maritime and surveying capabilities predating known history. This civilization, they suggest, mapped the world's coastlines during a warm period and passed its knowledge down through a chain of copies that eventually reached medieval and Renaissance mapmakers. The original mapmakers are long forgotten, but their work, degraded and distorted, survives. The skeptics counter that the maps are easily explained by educated guesswork, copying errors, and the human tendency to see patterns where none exist. The Antarctic coastline on these maps doesn't actually match the real coastline very well if you look closely. The similarities are cherry-picked, the differences are ignored, and the idea of a pre-Ice Age maritime civilization is extraordinary, requiring extraordinary evidence that simply doesn't exist. You float in the space between these positions, not committing to either one. The Piri Reis map is a genuine mystery, regardless of what it actually depicts. It reminds us that the past contained knowledge we've lost, that maps and books and ideas have vanished into the void of history, leaving only fragments and traces and questions. Whether those fragments point toward lost civilizations or just lost libraries, they're worth thinking about. The night outside your window is getting deeper now, and the Piri Reis map fades from your imagination like ink dissolving in water. You don't need to solve this mystery. You just need to appreciate it. Hold it gently. Let it remind you that the past is bigger and stranger than any textbook can contain. The Ottoman admiral did his best with the sources he had. You're doing your best with the sources you have. Across 5 centuries, that shared effort connects you. 2 people trying to understand a world that refuses to fully reveal itself. You drift, and the maps drift with you. All those coastlines and continents blurring together into a soft, indistinct whole. The ice will keep its secrets, the parchment will crumble eventually, but the questions will remain, passed down from generation to generation, as long as there are people curious enough to ask them. You leave the maps behind and turn inward now, towards something more personal, the story written in your own cells. Your DNA carries information not just about what you are, but about where you came from, and the more we learn to read that story, the more puzzles we find. The human genome is a palimpsest, a document written over and over again, earlier layers partially erased to make room for new text. We carry within us the traces of every population that contributed to our ancestry, every migration and merger and bottleneck that shaped our species. And some of those traces are very strange indeed. About 70,000 years ago, something terrible happened to humanity. The population crashed to perhaps as few as 10,000 individuals. Some estimates go even lower, to just a few thousand. This is called the Toba catastrophe theory, named after the supervolcanic eruption in Indonesia that may have caused it. For a brief period in evolutionary terms, humans were endangered, our species teetering on the edge of extinction. We survived, obviously, but the genetic evidence of that bottleneck is still visible in our DNA. Compared to other great apes, humans have remarkably low genetic diversity, suggesting we all descend from a relatively small founding population. But here's where things get interesting. The Toba bottleneck isn't the only genetic mystery in human ancestry. There are others, stranger and harder to explain. When scientists first sequenced the Neanderthal genome, they discovered that most non-African humans carry between 1 and 4% Neanderthal DNA. We didn't just share the planet with Neanderthals, we interbred with them, absorbed them into our lineage, carried pieces of them forward into the present. And the Neanderthals weren't the only ones. There's also Denisovan DNA, from a population we only know from a few fragmentary fossils found in a Siberian cave. Denisovans contributed genetic material to modern populations in Melanesia and Australia. And there may be others, ghost populations, whose existence we can infer only from the genetic traces they left behind, having themselves vanished so completely that no bones or artifacts remain. Scholars still debate how many of these ghost populations existed, how long they persisted, and what happened to them. Some researchers suggest there may have been multiple waves of human-like species emerging from Africa, spreading across the world, developing their own cultures and technologies, and then disappearing, absorbed, replaced, or simply dying out. The genetic evidence suggests a history far more complicated than the simple story of modern humans emerging and conquering the world. Here's the quirky detail that might follow you into your dreams. In 2019, researchers found evidence of an unknown human ancestor in the DNA of West African populations, a ghost species that interbred with our ancestors about 50,000 years ago, but left no fossil record. We don't know what they looked like, where they lived, or what they called themselves. We only know they existed because their DNA survives in living people today. You think about this as you lie in the darkness, feeling the weight of all those ancestors pressing down on you. You're not a single line. You are a braided river, fed by countless tributaries whose sources have been forgotten. The person you are tonight is the result of mergers and migrations and encounters stretching back hundreds of thousands of years, most of which left no record except the silent testimony of your genes. And if that's true for humans, what about the deeper past? What about the species that came before us, the failed experiments in consciousness, the intelligent creatures that might have risen and fallen without leaving any genetic trace in modern lineages? The genetic record, like the fossil record, is incomplete. It shows us only what survived, what was passed down, what happened to contribute to living populations. Everything else is silence. The ghost populations haunt you gently as you drift towards sleep. They were real once, as real as you are now, as full of hopes and fears and dreams. And now they're just anomalies in a DNA database, statistical shadows that hint at stories we'll never fully hear. You carry pieces of them with you, quite literally, and that's a kind of immortality, even if it's not the kind they would have chosen. The bottlenecks and the ghosts fade into the background hum of your mind, becoming part of the vast, soft darkness that's settling over everything now. You are descended from survivors, from the ones who made it through the catastrophes and the collapses and the extinctions. That's something. That's worth remembering as you close your eyes and let the ancient story written in your cells continue for another night. You pull back now, further out, past the confines of Earth entirely, and find yourself floating in the familiar territory of a very famous question. The Fermi paradox. You've probably heard of it. If the universe is so vast and so old, with billions of galaxies containing billions of stars, many of which have planets, some of which must be habitable, then where is everybody? Why haven't we found evidence of extraterrestrial intelligence? The usual answers focus outward. Maybe intelligent life is rare. Maybe civilizations destroy themselves. Maybe they're out there, but we haven't looked in the right way. But tonight, you're going to invert the question. Instead of asking where the aliens are, you're going to ask a different version. What if the Earth itself is the answer? Consider this. The Fermi paradox assumes we're looking for the first civilization, the first intelligence in our cosmic neighborhood. But what if Earth has already hosted multiple cycles of intelligent life, each one rising and falling without contact, each one leaving no trace detectable by its successors? The paradox might not be about the emptiness of space, but about the fullness of time. 1 billion years is incomprehensibly long. Earth is 4.5 billion years old. For most of that time, life has existed in some form, and for the last 500 million years, complex multicellular life has diversified in ways we're still cataloguing. If intelligence can arise once, and it did, because you're here thinking about this, then why not twice, or 10 times, or 100? The Silurian Hypothesis, remember, doesn't claim ancient civilizations existed. It just points out that we haven't actually ruled them out. Scholars still debate whether intelligence is a likely outcome of evolution or a freakish anomaly. The fact that it took 4 billion years to produce humans suggests it's not exactly inevitable. But 4 billion years is a lot of time, and evolution is a process of endless experimentation. Maybe intelligence emerged multiple times but didn't last. Maybe there were Triassic philosophers and Devonian engineers, brief flickers of consciousness that burned bright and then went dark, swallowed by extinction events that reset the board. Here's the quirky detail that ties this together. The same factors that make interstellar communication difficult, the vast distances, the speed of light limit, the sheer improbability of two civilizations existing at the same time, apply equally well to communication across deep time. A civilization that existed 100 million years ago would have no way to reach you, even if they'd wanted to. Their radio signals, if they sent any, would have passed this point in space long before Earth even formed. Their artifacts would be dust. Their stories would be silence. The inverted Fermi paradox suggests that the loneliness we feel when we look at the stars might be the same loneliness we'd feel if we could look backward through time. We are isolated not just in space, but in time, cut off from any predecessors who might have shared our questions and our wonder. If they existed, they're gone. If we go, we'll be gone too. And whoever comes after, if anyone comes after, will ask the same questions and find the same silence. You find this strangely comforting as you lie in the darkness. The universe isn't ignoring you. It's not withholding answers out of cruelty. It's just big and old and indifferent, a stage so vast that the actors rarely overlap. You're performing your scene, and maybe someone performed a scene before you, and maybe someone will perform one after, but you'll never meet. That's not sad. It's just the nature of the play. The inverted paradox settles into your consciousness like a stone dropping through still water, sending ripples out toward the edges of your awareness. You don't need to solve it. You don't need to prove that ancient civilizations existed or didn't exist. You just need to appreciate the question, the way it reframes your place in the universe, the way it makes both time and space feel deeper than you'd realized. The stars are still there, outside your window or beyond the roof of your building, indifferent and beautiful. They've been shining for billions of years, illuminating dramas you'll never know about, and they'll keep shining for billions more. You're a brief flicker in all that light, a single consciousness wondering about its context. And that's enough. That's more than enough. That's a miracle, even if no one remembers it after you're gone. The paradox fades now, replaced by a soft, heavy peace that spreads through your limbs and settles behind your eyes. The questions don't go away, but they stop demanding answers. They become part of the background, like the hum of that fan in the corner, like the rhythm of your own breathing. You are here, now, wondering. That's the only thing you know for certain. And tonight, that certainty is enough. You return now from the cosmic contemplation of the Fermi paradox to something more tangible, more grounded in the patient work of scientists who spend their careers staring at rocks. Because if ancient civilizations existed, whether human, pre-human, or something else entirely, the evidence would have to be hiding somewhere in the geological record. The question is, what would we even be looking for? This is the domain of technosignatures, a term usually applied to the search for extraterrestrial intelligence, but equally relevant to our hunt through deep time. A technosignature is any measurable effect that technology leaves on its environment. Chemical traces, isotopic anomalies, synthetic materials, sudden changes in the composition of air or water or rock. If an industrial civilization existed millions of years ago, it would have left technosignatures. The challenge is distinguishing them from natural processes that can produce similar effects. You imagine yourself as a geologist, core sample in hand, squinting at thin layers of sediment under a microscope. What would make you sit up and take notice? What anomaly would make you whisper to yourself, "That's not supposed to be there"? Let's start with carbon. When you burn fossil fuels, you release carbon dioxide into the atmosphere, and that carbon has a distinctive isotopic signature. Fossil carbon is depleted in carbon-13 compared to atmospheric carbon, because plants preferentially absorb the lighter isotope during photosynthesis. A sudden spike in light carbon in the geological record would suggest massive burning of organic material, exactly what an industrial civilization would do. And here's the thing, we've found such spikes. The Paleocene-Eocene thermal maximum, about 56 million years ago, shows a rapid injection of light carbon into the atmosphere, causing global temperatures to spike by 5 to 8 degrees Celsius. Scholars still debate what caused the PETM. The leading theories involve volcanic activity releasing methane from seafloor deposits, or massive wildfires, or some combination of geological processes. Nobody seriously proposes that an ancient civilization burned through their fossil fuels and triggered the warming. But the Silurian Hypothesis asks us to consider, would we recognize an industrial carbon spike if we saw one? The PETM happened over thousands of years, too slow to be a definitive industrial signature but fast enough to be unusual. It's probably natural, almost certainly natural, but almost certainly leaves a sliver of space for wondering. Here's a quirky detail for your drifting mind. Synthetic molecules might be the smoking gun that would prove ancient industry existed. Certain chemicals simply don't occur in nature. Chlorofluorocarbons, for example, or certain plasticizers and flame retardants. If we found CFCs in 50-million-year-old ice cores, that would be extraordinary, inexplicable by any natural process. So far, we haven't found anything like that. But we also haven't looked very hard. The search for ancient technosignatures is not a well-funded field of research, partly because the hypothesis seems so outlandish, and partly because there's no obvious place to start digging. Radioactive isotopes offer another avenue. Nuclear technology produces specific signatures, elevated levels of plutonium-244, unusual ratios of uranium isotopes, traces of fission products that don't occur naturally. A civilization that went through a nuclear phase, whether for energy or for weapons, would leave detectable traces for millions of years. The half-life of plutonium-244 is about 80 million years, meaning that if someone was splitting atoms 100 million years ago, we might still find the evidence today. But here's the problem. We'd have to know where to look. The Earth is big, and the geological record is incomplete, and the specific layers that might contain technosignatures could be buried under mountains or subducted into the mantle or simply eroded away. Finding a plutonium anomaly would require luck as much as skill. The right rock, the right layer, the right equipment, the right scientist asking the right questions. You let the technosignatures wash over you, a catalogue of possible evidence that hasn't been found yet, might never be found, might not exist at all. The absence is not proof of anything. It's just absence, the default state of the universe, the silence that fills the gaps between signals. Maybe someone was here before, burning carbon and splitting atoms and leaving their mark on the planet. Maybe not. The rocks aren't talking, and you're too tired to interrogate them. The geologist in your imagination sets down the core sample and rubs their eyes. The microscope light is giving them a headache. They'll come back tomorrow, run more tests, keep searching. That's what scientists do. They keep looking even when they're not sure what they're looking for. And that persistence, that stubborn refusal to accept mystery as final, is itself a kind of technosignature. A mark that intelligence leaves on the universe, detectable only to other intelligences patient enough to notice. You've been circling around it all night, touching it briefly and then moving on, but now it's time to face the great dying directly. This is the Permian-Triassic extinction event, the most devastating mass extinction in Earth's history, and it wants to teach you something about how completely the slate can be wiped clean. About 252 million years ago, something terrible happened. We're not entirely sure what. Theories include massive volcanic eruptions in what is now Siberia, sudden release of methane from the ocean floor, runaway greenhouse warming, ocean acidification, or some nightmarish combination of all of these. Whatever the cause, the result was catastrophic. Approximately 96% of all marine species went extinct, along with about 70% of terrestrial vertebrate species. The world that emerged from the Permian-Triassic boundary was fundamentally different from the world that went in. You try to imagine it. Though imagination fails at these scales, forests die, oceans turn anoxic, their waters choked with hydrogen sulfide, poisonous to most life. The food webs collapse from the bottom up as the organisms that everything else depends on simply vanish. For millions of years afterward, yes, millions, the recovery is slow, stuttering, repeatedly set back by aftershocks and secondary crises. The age of dinosaurs that follows is built on the ruins of the age of everything else. A new world rising from the ashes of one that will never return. Scholars still debate the exact sequence of events that caused the Great Dying, and new theories emerge every few years. But one thing is clear: whatever existed before the Permian-Triassic boundary, whatever ecosystems and species and relationships had developed over the preceding hundreds of millions of years, most of it was erased. Not just killed, but erased. The evidence destroyed along with the organisms. Here's where the Silurian Hypothesis becomes genuinely sobering. If a civilization existed before the Great Dying, say, in the Permian period, when complex ecosystems had already been developing for over 200 million years, what would remain of it after an extinction event that killed 96% of all marine species? The rocks themselves were transformed. The ocean floor was buried under layers of dead organic matter. The continents were still assembling, and the tectonic shuffling of the following eons would scramble any remaining evidence beyond recognition. The quirky detail for tonight, one of the geological signatures of the Permian-Triassic boundary, is a distinctive layer of rock called the Permian-Triassic boundary clay. In some locations, it contains unusually high concentrations of certain elements, arsenic, antimony, cadmium, that have led to speculation about oceanic poisoning. But here's the thing: we don't fully understand why those elements are there. Natural processes can explain it, probably. Volcanic outgassing, hydrothermal vents, ocean chemistry. But probably is not definitely, and the boundary clay remains one of the most studied and least understood layers in the geological record. You imagine, just for a moment, a Permian civilization watching the sky darken as the Siberian traps erupted. They would have had no context for what was happening, no understanding of the geological forces about to erase everything they'd built. Maybe they had scientists who noticed the changes and tried to warn the others. Maybe they had artists who painted the red sunsets, not realizing the color came from ash and poison. Maybe they simply went about their daily lives, concerned with the usual concerns, right up until the end. The Great Dying reminds you that the universe doesn't negotiate. It doesn't give warnings that a civilization could understand and respond to. It just does what it does, vast and impersonal, and whatever is in the way gets swept aside. Your own civilization is not exempt from this. The same forces that killed 96% of marine species 252 million years ago are still at work today. The volcanoes are still there. The methane is still trapped under the permafrost. The ocean chemistry is still balanced on a knife's edge. But you're not here to be frightened. You're here to drift, to wonder, to let the immensity of deep time become a kind of lullaby. The Great Dying happened, and life continued. The dinosaurs rose from the wreckage and ruled for 165 million years. And then they fell, and mammals rose, and here you are, wondering about all of it from the warmth of your bed. Extinction is not the end. Not for life, not for the planet, not for the possibility of intelligence emerging again and again and again. The Permian fades into the background now, joining all the other deep time chapters we visited tonight. It's just one layer in the rock, one page in the book, one moment in the 4 billion year story of life trying to understand itself. You don't need to memorize the details, you just need to let them wash over you, softening the edges of your consciousness, reminding you that you're part of something vast and ongoing and utterly beyond your control. You rise from the land now and descend into water, Not the shallow coastal waters we explored earlier, but the deep ocean, the abyssal plains, the midnight zones where sunlight has never reached and never will. Because if we're looking for civilizations we'd never find, we should probably talk about the ones that might never have left the sea. Consider this. Intelligence evolved on land, in primates, exactly once that we know of. But the conditions that produce intelligence, complex social structures, problem-solving demands, competition for resources, exist in the ocean too. Dolphins are intelligent, so are orcas, and various species of whales. Octopuses are eerily clever, solving puzzles, using tools, escaping from aquariums with what can only be described as premeditation. Cuttlefish communicate through colour changes so rapid and complex that scientists are still trying to decode the language. What if intelligence evolved in the ocean long before it evolved on land? What if there were civilizations beneath the waves, cetacean cities or cephalopod societies that rose and fell without ever leaving a trace we could find? The problem, of course, is evidence. Ocean civilizations, if they existed, would face almost insurmountable challenges in leaving behind artifacts. They couldn't use fire, water and combustion don't mix, so metallurgy would be out of the question. They couldn't develop writing in any form that would survive, since paper and clay tablets and stone inscriptions all require air to be created and preserved. Whatever technology they developed would have to be based on biology, on cultivated organisms, on structures grown rather than built. And those structures would rot, dissolve, be consumed by bacteria and scavengers and the relentless patience of saltwater. Scholars still debate whether complex intelligence could even develop without fire. Fire gives you metallurgy, which gives you tools, which gives you technology, which gives you civilization, or so the argument goes. An aquatic species would be stuck at a pre-technological stage forever, no matter how intelligent it became. But this argument assumes that our path to civilization is the only path, that technology must look like our technology, that intelligence must express itself in the ways we recognize. Here's the quirky detail for tonight. Octopuses have distributed nervous systems with significant neural processing happening in their arms, independent of their central brain. An octopus can solve a problem with one arm while another arm explores something else entirely. Their intelligence is architecturally different from ours, distributed rather than centralized. What would a civilization built by such minds look like? We literally cannot imagine it, because our imaginations are constrained by the architecture of our own brains. You drift now through imaginary depths, past bioluminescent creatures trailing light through the darkness, past hydrothermal vents where life thrives on chemical energy rather than sunlight. The ocean is alien, even though it's right here on Earth. We know more about the surface of Mars than we know about the deep sea floor. Whatever happened down there in the billions of years when life was exclusively aquatic remains largely mysterious. The earliest fossils of complex life are marine. For over 3 billion years, life existed only in the water, single-celled at first, then multicellular, then increasingly complex. The oceans were the laboratory where evolution ran its experiments, developing all the basic body plans, all the fundamental strategies for survival, before anything crawled onto land. If intelligence was going to emerge early, it would have emerged there. But there's no evidence, no anomalous structures, no techno-signatures, no mysterious fossils that suggest tool use or social organization beyond what we see in modern marine animals. The absence could mean that ocean intelligence never happened, that the conditions simply never aligned, or it could mean that ocean intelligence happened and left no trace, which is exactly what we'd expect from a civilization built without fire, without metal, without anything durable enough to survive even a few thousand years, let alone a few million. You find yourself strangely at peace with this uncertainty. The ocean keeps its secrets, and maybe that's appropriate. Not everything needs to be known. Not every question needs an answer. The deep sea has been dark and quiet for billions of years, and it will continue to be dark and quiet long after you're gone, holding whatever it holds, revealing whatever it chooses to reveal. The pressure of all that water, miles above the abyssal plain, feels almost comforting from here in your bed. You're not down there, you're up here, safe and warm and breathing air. But the ocean is part of your heritage, part of the story that made you possible. Whatever happened in those depths, whatever intelligences might have flickered and faded in the darkness, they're your distant cousins. Their atoms are your atoms. The story continues. You surface from the ocean depths and find yourself on dry land again, but this time you're listening rather than looking. The evidence of lost civilizations might not be in the rocks or the ice or the water, it might be in the stories. The myths and legends that every culture carries, passed down through generations, transformed by telling and retelling until their origins are lost in the mist of deep time. Every culture has origin stories, creation myths, flood myths, tales of gods and monsters and heroes from a golden age. The mainstream explanation is that these stories are psychological. They reflect universal human experiences, our need to explain the world, our fear of chaos and death, our hope for meaning. And that's probably true as far as it goes. But there's another possibility, one that hovers at the edges of anthropology and archaeology. What if some myths preserve actual memories? We touched on flood myths earlier, the remarkable consistency of deluge stories across cultures that had no contact with each other. But the phenomenon extends beyond floods. There are myths of flying machines, the Vimanas of Hindu tradition, the flying chariots of Greek and Persian legends. There are myths of underground cities, Agartha, Shambhala, the hollow earth traditions that surface in cultures from Tibet to the Americas. There are myths of god-kings with advanced knowledge who arrived from elsewhere, taught humanity the arts of civilization, and then departed or died. Scholars still debate whether these mythological patterns represent shared human psychology or shared human history. The psychological explanation is more parsimonious. It requires no lost civilizations, no extraordinary claims about the past. But the historical explanation is more tantalizing, suggesting that fragments of real events have been preserved in the amber of story, distorted but not destroyed. Here's the quirky detail for tonight. The Aboriginal Australians have oral traditions describing geological events that can be independently verified, coastlines that flooded, volcanoes that erupted, land bridges that disappeared. Some of these events happened over 7,000 years ago, and the stories have been passed down with remarkable accuracy across hundreds of generations. If oral tradition can preserve accurate information for 7 millennia, what might it preserve across even longer spans? The Dogon people of Mali have astronomical knowledge about the Sirius star system that wasn't confirmed by Western science until the 20th century. They knew that Sirius has a companion star, invisible to the naked eye, that orbits in a 50-year cycle. The skeptical explanation is that this knowledge came from contact with European astronomers in the 19th century. The alternative explanation, that the Dogon inherited astronomical knowledge from a much older source, is controversial but not easily dismissed. You're not here to adjudicate these disputes. You're here to drift, to wonder, to let the myths whisper their ambiguous truths into your sleepy consciousness. The Vimanas might have been metaphors or dreams, or distorted memories of hot air balloons, or something else entirely. The underground cities might be psychological projections of the womb, the grave, the unconscious mind, or they might be garbled accounts of real places, real refuges, real civilizations that went below when the surface became inhospitable. The thing about myths is that they're true in a way that facts aren't. They're true to the human experience, true to the fears and hopes and confusions that every generation inherits from the ones before. Whether or not there were literally flying machines in ancient India, the idea of flying machines was important enough to be preserved, elaborated, passed down. The myth carries meaning, even if it doesn't carry history. And maybe that's enough. Maybe the myths aren't evidence of lost civilizations, but something better. Evidence of continuous civilization, the unbroken chain of human storytelling that connects you to ancestors who lived when the glaciers still covered half of Europe. You're part of that chain. The stories you tell, the questions you ask, the things you wonder about as you fall asleep. Their links being forged, contributions to a tradition that might outlast any individual artifact. The myths fade into the background now, becoming a kind of hum, a chorus of ancestral voices murmuring in languages you don't quite understand. They're not demanding anything from you. They're just there, doing what they've always done, carrying meaning forward through time, and you're listening, even as your eyelids grow heavy, even as the words dissolve into feeling and the feeling dissolves into sleep. You've been wandering through possibilities all night, exploring the question of whether we're the first, without ever quite arriving at an answer. Now it's time to sit with a harder question, the one that's been lurking beneath all the others. Why does it matter? If ancient civilizations existed and vanished, leaving no trace, what does that mean for us? The sobering answer is that it means we could vanish too. Not just die, every individual dies, but vanish, leaving no trace, becoming a thin layer of sediment in future rock that some hypothetical future intelligence might puzzle over for a moment before moving on. The same forces that would erase ancient civilizations would erase ours. Erosion, subduction, metamorphism, the patient grinding of geological time. We like to think we're different. We've built monuments, the pyramids, the Great Wall, Mount Rushmore, that we imagine will last forever. But forever is a long time, and forever in geological terms is incomprehensibly longer than the span of human civilization. The pyramids are about 4,500 years old. In 4.5 million years, they'll be rubble, their stones scattered by earthquakes and erosion, their location changed by tectonic drift. In 45 million years, they'll be atoms, recycled into new rock, new soil, new life. Nothing we build will survive on geological timescales. Nothing. Scholars still debate whether any human-made structure could last more than a few million years, and the consensus is bleak. Even our most durable materials, concrete, stainless steel, certain ceramics, will eventually fail. The only things that might survive are synthetic molecules that don't exist in nature, radioactive isotopes from nuclear technology, and the carbon signature of burning fossil fuels. These are our techno-signatures, the fingerprints we're leaving on the planet whether we mean to or not. Here's the quirky detail for tonight. The most durable record of human existence might be the moon. The Apollo astronauts left footprints, flags, equipment, and plaques on the lunar surface, and because the moon has no atmosphere, no weather, no erosion, these artifacts could theoretically last for millions of years. If Earth is wiped clean, if our species vanishes without a trace, there might still be footprints on the moon, waiting for someone or something to find them. The lesson of the Silurian Hypothesis isn't that ancient civilizations existed, it's that civilizations can vanish so completely that their existence becomes undetectable. And if that's true for hypothetical predecessors, it's true for us too. The universe doesn't owe us permanence. It doesn't owe us memory. It will forget us just as easily as it forgot everyone who came before, and the forgetting will be so thorough that future minds won't even know there's something to forget. But here's the counterpoint. The thing that makes this sobering truth bearable. The point of existence isn't to be remembered. It's to exist. You're alive right now, in this moment, thinking these thoughts, and that's not diminished by the fact that the thoughts will eventually stop and the thinker will eventually be recycled into something else. The value of experience is not contingent on its permanence. The ancient civilizations that might have existed, if they existed, had their own moments, their own experiences, their own loves and fears and triumphs. Those moments were real, even if no record remains. The absence of evidence is not evidence that the experience didn't matter. It just means the universe has moved on, as it always does, as it always will. You're moving on too, slowly, gently, toward the sleep that's been waiting for you all along. The question of permanence resolves itself when you stop demanding permanence. You're not here to last forever. You're here to be here, now, for as long as you get, and to contribute whatever you contribute to the story that will continue with or without you. The humility of this perspective settles over you like a second blanket. You're not the protagonist of the universe. You're not even the protagonist of Earth's history. You're a moment, a flicker, a brief arrangement of matter that happens to be aware of itself. And that's miraculous enough without needing to last. You fast forward now, leaving the present behind, hurtling into a future as distant from now as the dinosaurs are from us, 50 million years from today. What would future paleontologists, whatever form they take, find of us? The thought experiment is surprisingly specific, because scientists have actually worked this out. They've asked, what will the geological record of the Anthropocene look like to investigators in the far future? And the answers are both humbling and oddly reassuring. First, the layer. There will be a distinct stratum in the rock, a thin, dark line marking the period of human industrial activity. It will contain elevated levels of heavy metals, lead from gasoline, cadmium from batteries, mercury from coal burning. It will contain plastics, degraded but still detectable as synthetic polymers that don't occur naturally. It will contain fly ash from power plants, spherical carbon particles that could only have been created by combustion. This layer will be global, appearing in sediments on every continent and ocean floor, unmistakable evidence that something unusual happened. Second, the fossils. Our bones will be rare. We've buried most of our dead in ways that don't promote fossilization, but our domesticated animals will be everywhere. Chicken bones, remember. We've raised so many chickens that their remains will dominate the vertebrate fossil record of this era. Future paleontologists will puzzle over the sudden appearance of billions of identical birds, unlike anything before or after, spread across every continent. They might not understand what chickens were for, but they'll know something very strange was happening. Scholars still debate how long it will take for the Anthropocene layer to become recognizable as a distinct geological unit. Some estimates suggest a few 100,000 years, others push it to several million. But eventually, if anyone is looking, they'll find us. Or rather, they'll find the marks we left on the planet. Here's the quirky detail for tonight. One of the most durable artifacts of human civilization might be nuclear waste. The spent fuel rods from reactors contain isotopes with half-lives measured in millions of years. Plutonium-239 will still be detectable in 240,000 years. Neptunium-237 will persist for over 2 million years. Iodine-129 has a half-life of 15.7 million years. If future investigators find concentrations of these isotopes in the rock, they'll know immediately that they're looking at the product of technology, because these materials simply cannot form naturally. You imagine those future investigators now. They might be descendants of ours, humans who survived whatever comes next and rebuilt from the wreckage. They might be an entirely new species, something that evolved after we were gone, intelligent in ways we can't imagine. They might be machines, artificial minds that outlasted their biological creators and inherited the Earth by default. Whoever they are, they'll stand at the same kind of boundary we study today, the Anthropocene layer, And they'll ask the same questions we've been asking all night. What were they like? What did they want? Why did they vanish? The answers will be partial at best, distorted by time and distance, filtered through interpretive frameworks we can't predict. Maybe they'll imagine us accurately. Maybe they'll get us completely wrong. Maybe they'll conclude that we were a natural phenomenon, a brief geological aberration, not really intelligent at all. The irony is delicious and slightly painful. We've been wondering all night whether ancient civilizations existed and left evidence that we missed. Now we're contemplating the evidence we'll leave for future minds, evidence that will be just as ambiguous, just as open to interpretation, just as susceptible to being overlooked or misunderstood. You're not disturbed by this. You're soothed by it, actually, by the symmetry of the thing. The questions we ask about the past are the same questions the future will ask about us. We're all in this together, past, present, and future, connected by the same confusions, the same limitations, the same hunger to understand a universe that will never fully reveal itself. The future fades back into the unknowable, where it belongs. You visited it briefly, seen what you could see, and now you're returning to the present, to this night, to this bed, to this gentle slide towards sleep. The chickens will remember you. That's more than most species get. You've arrived, finally, at the place where all questions about lost civilizations eventually lead, not to answers, but to acceptance. The mystery remains. It will always remain. And somehow, that's exactly as it should be. We've travelled far tonight, you and I. We've stood in laboratories where scientists asked impossible questions about deep time. We've watched continents drift and species rise and fall across spans of years that make human history look like a footnote. We've searched for techno-signatures in ancient rock, peered beneath the ice of Antarctica, dove to drowned coastlines, and listened to myths that might carry whispers of forgotten truths. And at every turn we found the same thing: uncertainty. This could be frustrating, but it isn't. Not really. Not when you let yourself settle into it. The uncertainty is the point. The question of whether we're the first is not a puzzle to be solved, but a koan to be contemplated, a tool for shifting perspective, a reminder that the universe is vastly larger and stranger than any single mind can comprehend. Here's what we know for certain. Intelligence has arisen at least once on this planet. You're proof of that. Whatever you are, a collection of atoms arranged in an improbable pattern, a temporary eddy in the flow of energy from the sun, a point of awareness in an otherwise indifferent cosmos. You exist. You're thinking. You're wondering. Against all odds, against all the forces that have erased and recycled and forgotten, here you are. Scholars still debate whether intelligence is an inevitable outcome of evolution or a freakish accident. We have only one data point, ourselves, and you can't draw a trend line from a single dot. Maybe intelligence emerges on every planet that harbours life long enough. Maybe we're the only ones, an anomaly, a cosmic lottery winner who beat odds so long they're practically infinite. We don't know. We can't know. And the not knowing is itself a kind of information, a boundary marker for human understanding. Here's the final quirky detail of the night, something to carry with you into your dreams. The atoms in your body have been part of other things. They've been stars, interstellar dust, planets, bacteria, dinosaurs, trees, maybe even intelligent beings we'll never know about. You're not separate from the history of the universe. You're a continuation of it, a momentary arrangement of matter that happens to be asking questions about all the previous arrangements. The ancient civilizations we've been wondering about, if they existed, are part of you now. Their carbon is your carbon. Their calcium is in your bones. The stardust that made them is the same stardust that makes you, cycling endlessly through forms and configurations, never created, never destroyed, only transformed. And when you're done, when this particular arrangement dissolves and the atoms scatter to become part of new configurations, you'll join them. Not in any mystical sense, not in any afterlife or spirit realm, but in the simple, beautiful physics of a universe that wastes nothing. The matter that is you will become the matter that is something else, and the process will continue, as it always has, as it always will. This is the deepest comfort available to a conscious being. The knowledge that you are not separate, not isolated, not a brief flicker against an uncaring void, but a wave in an ocean that has been waving for billions of years and will continue long after this particular wave has merged back into the whole. The question of whether we're the first civilization doesn't need an answer. It needs to be felt, to be held, to be appreciated for what it offers. A glimpse of the vast, ongoing, endlessly creative process of which you are an inseparable part. You close your eyes now if they weren't already closed, and you let the questions go. They'll be waiting tomorrow if you want to pick them up again. The mysteries will still be mysterious. The past will still be past, the future still unwritten. But right now, in this moment, there's nothing to solve. There's only this breath, and the next one, and the soft darkness settling over everything like a blessing you didn't know you needed. The night has grown very quiet now, and the vast expanses of time we've wandered together are folding themselves up, becoming small enough to fit inside this peaceful moment. You don't need to carry them with you into sleep. They'll keep themselves patient and unchanged, ready for whenever you want to wander again. Your body is heavy in the best possible way, sinking into the mattress like something that has finally found its place. The questions about ancient civilizations, about what came before, about what will come after, they're not gone, but they've grown soft, diffuse, more like background music than urgent demands. Let them fade. Let them become part of the quiet. The atoms that make you are ancient beyond measure, and they'll continue long after this brief arrangement dissolves. But tonight, they're arranged as you, and you are here, and that's enough. More than enough. The universe has been doing this for billions of years, arranging and rearranging, forgetting and remembering, creating and destroying, and somehow, against all probability, this particular arrangement gets to experience this particular piece. Your breathing slows without effort. Your thoughts grow fuzzy at the edges, blurring into something that isn't quite thought anymore, something softer and deeper. The lost civilizations, if they existed, are at peace too. Not because they achieved anything permanent, but because impermanence was always the deal. They knew it, or they didn't. But either way, the universe held them gently, just as it's holding you now. Tomorrow will bring new questions, new wonders, new reasons to be amazed at the strangeness of existence. But tonight is for rest. Tonight is for letting go of the need to know, and simply being part of the mystery instead. Sleep well, you've earned it. Sweet dreams,